talking about a couple of three-dimensional objects. So we have prism, cylinder, pyramid, and cones. Okay, so we are going to talk about those four objects, three-dimensional objects. We are going to talk about the volume, and we are going to talk about the surface area. So the total surface area of three-dimensional object can be found by finding the sum of the area. Each of the shape can make up the surface of the objects. So that's why we're trying to think about the net. Okay, that's why we're trying to think about the net. So for a cylinder, if you can draw a cylinder at the left-hand side, so that's a three-dimension shape. Okay, that's a three-dimension shape. So it's a cylinder here. So if you think to cut it, okay, straight along the side, and get the two top and bottom circle, okay, beside that. So what you will have is a rectangle. Have a rectangle. Okay, we will have a rectangle and we have two circles. So if you can think about like that's a rectangle, we can make it into a cylinder like that way. Okay, if we can glue here, that will be a cylinder. Okay, it's not very beautiful, but when you cut it, that will be a rectangle. And then we have two circles. The top one and the bottom one. They should be the same size, but my sketching is not that accurate. So, oh my God, it's even worse. Okay, some two circles, they are identical. Okay, two identical circles. The circumference of the circle must be the same as this length. Okay, the circumference, like the length of the circumference, must be the same as that length. Because think about that. If you use a rectangle to make a cylinder, okay, that's the circle. That is the circumference. When you expand it, that is still the circumference. So the circumference of the circle must be the same as that line. So if we can use circumference C1, circumference C1, that will be the same as the circumference C1 as well. And the width of this called the height. Okay, called the height of the cylinder. So also we will have radius as well. So we have radius as well. So that's the center. We will have the radius here. That's the radius. Yeah, that's the net for the cylinder. And then if we think about the net for the cone, so if we sketch a cone here, okay, it will be this. We have the radius R as well. Okay, we can label some value. We have the radius R. We will have this length called slot height. Okay, S. We use S to represent that. Okay, this is S as well. If it's a right chord, so those two will be S. What do you think the net will be if you cut it? We'll definitely have a circle, like for the bottom. So what's that face look like? Circle? Sector. Sector, that's right. It's a sector. So well, it can be a minor sector or can be a major sector. So it can be a sector like this. My sector is terrible. It can be a sector like this. Oh my God, I don't want to look at it. Okay, that's a sector. Okay, that's a sector. That's the center. Okay, where is the slant height? The two radius. Okay, that's the S. Okay, that's the S. Okay, also we have the base. The base will be a circle. Okay, the circumference will be the same as what? The edge of the sector. So will be here. That length will be the same as the circumference length. Okay, so when you glue that together, that becomes the circle at the bottom. So that will be the circumference length. Oh, well, it's not necessarily always be a sector like a major sector. It can be a minor sector as well. A minor sector can make a cone as well. It depends on the angle or the size or the height. It's all different decide whether it's a major or minor sector. So that's one of the possibility. Okay, rectangular prism. What that shape is like? What the shape looks like? It's a rectangular, just that. Okay, it's just that. Well, I know if I expand that, we'll have like 6 rectangle. Okay, 6 rectangle. So if I say that's A, that's B, and that's C, we'll have so let's say that's AB, AC, and CB as well. So CB. So all times by 2. Okay, there will be 6 faces, and each one is a rectangle shape. And you have AB, AC, and BC, and each of that you have 2 pieces of that. Okay, next one is triangular prism. So it will be a triangle, top and bottom, and it's all straight lines. So I can sketch it. Okay, that's a triangular prism. Let's say we have the triangle is not necessarily an isosceles triangle, or not necessarily to be a right angle triangle, or it's like or not equilateral triangle. So I just give a random length ABC here. Okay, just a random length ABC here. So when you cut that, what do you think the net will look like? 2 triangles, identical triangles, top and bottom. So that's the triangle ABC. Okay, times by 2, A, B, and C. And what's the other part looks like? The rectangle? 2. Okay, so 3 rectangles in total. Yes, 3 rectangles in total. Let's just draw 3 rectangles together. Let's say that's H, so that will be the height. So what's those lengths? What's those lengths? Think about when you put it back. What that become? ABC. That's right. Okay, when you put it back that way, that will be the perimeter of the triangle. So it's actually a big rectangle and two triangles there. Okay, that's the net for triangular prism. Any questions for this page? Okay, if you don't have any question, we will look at some of the formulas. By knowing like this, we'll investigate on some formulas. So first of all is the cylinder. So for the cylinder, we have 2 pi r squared and plus 2 pi r h. And I want the reasoning. Okay, so first of all, we have 2 circles. Too big. We have 2 circles. Why I just can't draw a circle? Okay, and I have a rectangle here. Okay, so we have radius r. So pi r squared is the area of the circle, right? Pi r squared is the area of the circle, and we have 2 of that. So it's 2 pi r squared. Okay, and as I said, that's the h, that's the height. So we have a cylinder like this, and we have radius r, and we have a height of h. Okay, we have a height of h. So what's this length? Okay, what is that red length here? The circumference. So what is the circumference? 2 pi r. That's right. So that's the 2 pi r. So the rectangle's height, rectangle's area will be length times width. So it's 2 pi r times h. That gives you the rectangle's area. So it's 2 circles plus the rectangle. So 2 pi r times h plus 2 pi r squared. Okay, next one. Next one is the cone. So, okay, this one is quite hard to reason. Okay, let's sketch one first. What you will know is the radius of the circle. Okay, the radius of the circle, and also I will know the slant height of the side. So I know S and I know R. Okay, I will finish this one, and I'm not going to keep for the rest too, but this will be a long proof. Okay, this will be a long proof. It will be good you understand where the formula comes from. So let's have a think. When we think about the net, that will be a sector. Well, I will draw a minor sector this time. My major sector looks terrible. So I will draw a minor sector here. So that's a minor sector. Let's say we have the S. That's the S. That's the S, right? And also I have a circle. Well, my circle I think might be too big because it only fits there. So I have a smaller circle here. So with radius R. Okay, with radius R. Okay, question is, what is this size? What is here? So use R to represent it. Give me a formula. 2 pi r. Okay, here will be 2 pi r because that's the bottom of the circle. So that's 2 pi r. So if that's 2 pi r, we can think about something like this. If I say this angle is theta, do you remember how we calculate the arc length? Like how we calculate the arc length? Like that was the proportion of the whole circle compared to the whole circle, and then times the whole circumference of that circle. So let's have a think. If I can make that back to a whole circle. It's very light. I hope you can see it, the green bit. Okay, I just draw a really big circle. What's the radius of this big circle? S. Yeah, the sector. So that's the radius, S. Because this is the radius. Okay, so we turn around, we draw a full circle. Let's have a think. I will write something and you try to think whether it's right or wrong. I will say theta over 360 degrees times 2 pi s equals to 2 pi r. Let me know how do you think about this equation, whether it's right or wrong. Right or wrong? What's 2 pi s? The circumference of the big circle. What's theta over 360? The proportion of the sector compared to the full circle. So the proportion times the circumference of the full circle give me the arc length. Okay, give me the arc length. So the arc length is 2 pi r. Now I want to know what is the proportion. So my theta over 360 is the proportion. So that equals to 2 pi r over 2 pi s. So I will divide this by that. Okay, move it to that side. So it's 2 pi r divided by 2 pi s. What that equals to? So the proportion theta over 360 is just r over s. Yes, the proportion is r over s. Now I know the proportion. Okay, don't worry about that yet. So let's put it away. Let's think about the area of the sector. Let's think about the area of the sector. So the area of the sector will be theta over 360 degrees times pi s squared. Is that correct? Okay, the proportion of the sector compared to the big circle times the area of the big circle will give me the area of the sector. That's what we're trying to find, because we want to find surface area. And we need to find the area of the sector and the area of the circle. So therefore, proportion times the area of the big circle will give me the area of the sector. Also from the circumference, we know that the proportion is just r over s. Okay, the proportion is just r over s. So substitute that to here. R over s times pi s squared. What we have is we can cancel this s with that s squared. What that gives me is pi r s. Okay, what gives me is pi r s. So this is the area of the sector. Okay, the area of the sector. This is the area of the circle. Pi r squared, very easy. Okay, pi r squared. That's the area for the small base circle. But for the larger sector, what we can find is pi r s. And why is pi r s? I have explained that. We need to find the proportion first. How do we find the proportion? By using the arc length. The full circle, the proportion of the circle, and find what is the proportion. The proportion is r over s. And we use that same proportion, because it's still the same sector, to times with the area of the full circle. And that gives us the area of the sector. That's why we have pi r s here. It's very hard to understand, oh, why we times the slant height, why we times the radius, and then we times pi. What's the reason? Okay, here is the reason why we do that way. Okay, so it's pi r s plus pi r squared. Area of the sector plus the area of the circle. Okay, and I want you to draw, I'm not going to explain those two. I want you to draw the diagram for me, and we can start directly tomorrow. So the first one is like a pyramid. We will sketch a pyramid. Really bad at sketching this one. It's not square pyramid. Okay, what we talk about is a square pyramid. Let's put a square. So it's a square at the bottom. So we are talking about the square pyramid. So we need to sketch two. The top one, this one, the L. The L is the base. Okay, the base, which is L. And the H. And the H. Well, if you have a square and it's a straight pyramid, the full triangle must be the same. Can you imagine that? The full triangle must be identical. So the H we're talking about is the height of the triangle. Okay, is the height of the triangle. So giving you the height of the triangle and the length of the square. Give you those two information and ask you to find the surface area. That's the first one. The second one. Okay, the second one still give you the length of the square, but instead of giving you the height, what gives to you is the S, the slant height here. Okay, knowing the slant height, and ask for what is the surface area. So no S, no L. That one's no L and no the H of the actual triangle. So that's the difference between those two. Okay, so you can have a think about that for use the rest of time. We still have 20 minutes. You can do some exercise or you can think about that question. So I will stop here today. I will start from this point tomorrow.